Okay, so first part of question 2. Given us 3 compounds. One is butan 1-ol. One is an isomer of butanol, but is the tertiary butyl compound. And then one is straight chain butanal. So if we just quickly draw the carbon backbone of these 3 compounds, we've got butanol, the first one. We then have the tertiary structure of butane, the butanol isomer, and then we have butanal, the straight chain version there. And first question is asking us then, so which of these organic compounds would reduce acidified potassium dichromate? So basically, which of these would be oxidized by potassium dichromate? So we need to have an oxidizable group. So obviously, butanol can be oxidized itself and would actually be oxidized to butanal in the first instance. The tertiary butyl compound here can't be oxidized because in order to create the double bond here, in order to create some sort of carbonyl structure, we'd have to get rid of one of these carbon-to-carbon bonds here, and we can't do that with potassium dichromate, so that compound won't oxidize. So we have the butanol straight chain isomer oxidizing to butanal, as we've said, but also butanal itself could be oxidized, and that will oxidize further to the carboxylic acid equivalent butanoic acid. Okay, and the half equation for that, which would then undergo, if we get rid of the one that doesn't actually work in the first place, then the dichromate ion is Cr2O7 2-, which exists in aqueous solution. That has to go to Cr3+ when it's reduced, and therefore when it is oxidizing the other substance, and so you need to balance that up. That equation has had within it some oxygens. We have to balance up the oxygens with the presence of water molecules. So we'd add 7 water molecules to that side of the equation. We've then incorporated hydrogens onto the right-hand side of the equation, so we have to introduce hydrogen ions to balance out those. And then what we do is try to balance out the charges using electrons. So on the left-hand side, there's a residual charge of 12 positives. On the right-hand side, there's 6 positives. So we've got 6 too many, 12 minus 6, 6 too many positive charges on the left-hand side. So we need to negate those with the addition of 6 electrons. And so it's therefore undergoing a reduction, because as you can see here, that is gaining electrons in the process of oxidizing the butanol to butanal here, and subsequently both of those would then go to butanoic acid if you were under reflux conditions.